have an object here that is a fairly kind of one-dimensional shape, and something that we can look at in physics in order to simplify our calculations is the centre of mass or the centre of gravity. So when we consider a one-dimensional shape like this kind of rectangle here, what we can think about are all the individual particles inside. Now they all have, all these atoms all have their own individual masses, and if we think about this in maybe a gravitational field, they all have their own individual weights. And what we can look at are the sum of all of these individual particles and think, well, how do they act as a whole? And what we can do is we can replace all of these individual masses by looking at effectively one large mass that appears to act at the centre. And, and where all the masses appear to act is what we call the centre of mass. Now we can also think about this in terms of the weight of all the objects, and we can also call the same point the centre of gravity. Now it's important to note that on Earth, where we have a fairly uniform field, the centre of mass and the centre of gravity are at exactly the same point. It's only perhaps if you had an immensely tall tower that stretches out into space where the strength of gravity at the top and the strength of gravity at the bottom are different, would we actually have the centre of mass being different to the centre of gravity. But what happens if we don't have this nice kind of regular shape? Perhaps we've got something which is a bit more irregular. What do we do then? Well, we can find the centre of mass, the point at which the weight or the mass appears to act, by hanging this up. Now if you hang it up from one corner and you let it just dangle, what's going to happen is that the centre of mass is going to end up directly beneath the pivot. And if you have some kind of plumb bob or a vertical line, you can basically draw a vertical line through that. Now if you repeat this at many other points, eventually you end up with the centre of mass must be down this line and this line, and if you do it from 3 points, then where they all cross over here is the centre of mass or the centre of gravity. But again, that's all fine. What happens if you have a really kind of complicated 3D shape? How do you find the centre of mass? Well, it's not so easy, and we don't really need to worry about it too much at this level of physics.